Today we will discuss about very much important topic of thermodynamics or as well as the Carnot theorem, that is heat engine. So in heat engine, what things you need? One is hot reservoir and another is cold reservoir. So from hot reservoir you should connect a engine, that is a hot reservoir is temperature is Th and cold reservoir temperature is Tc. So from hot reservoir QH amount of heat is taken to the cold reservoir, but during the transformation of QH some amount of energy is lost. So this lost energy is nothing but a work. So during this transformation of heat, hot reservoir to cold reservoir, some what amount of energy is lost. So lost energy this lost energy is we designated as W out. Okay, and the amount of energy which is transferred to cold reservoir, that is QC. Okay, that is QC. So if we put a heat engine between this hot reservoir and cold reservoir, we can easily evaluate the working efficiency or how much work is generated during the transform of QH to QC. So in this process, three steps should be remembered, or steps is involved. The first step is hot reservoir, second step is what, that is W out. Okay, and the third is the cold reservoir. So what's going on in every steps? Step 1, step 2 and step 3. So in the first step, the QH amount of heat is taken out from the hot reservoir. And in the second step, what is happening in the second step? W work out, that is performed by the sum of lost or loss energy during the transformation from hot reservoir to cold reservoir. Okay, so during this process, so during this process, some lost energy is happening in the second step, that is nothing but W out. So during this process you should keep in mind one thing always, that this QH, which is uh, the heat energy, is taken out from the hot reservoir, and the energy QC is transform or QC is QC amount of heat is going to the cold reservoir. These two heat energy value is never be the same, that is, in other words, in other words, this QH and QC, this QH and QC is never be the same, or this value is never be the same. Now if we go to the third step, what is happening here? In the third step, the remaining heat energy, that is is QC is remaining QC value of energy is entering in the cold reservoir. So this is QC is equals to QH minus of W. This is the process to evaluate the QC, that is the energy is entering in the cold reservoir. Okay, so So one question can come that how the QH is evaluated. QH should be, that is the how much energy is extracting or how much energy is taken out from the hot reservoir, that is QH is nothing but equals to QC plus of W out. That means when you sum up the QC amount of heat and the W working energy or W out, that would be the QH. And these in their unit is also the same. For QC is joule and W out is also joule, that is nothing but the energy unit. Okay. Now the one question is always came from the Carnot theorem concept. Here also the heat engine concept also the same thing is came in mind, that the efficiency of the heat engine, how much a engine is performed. Okay, so that would be calculation of efficiency of the heat engine. So what is the value? So efficiency, that is eta, how you calculate the eta value, that is what you get as a work divided by what you invested what invested as heat or energy, whatever you say, that is QH, okay, and what you get as a work, that is W out. Okay. If we compare with the Carnot theorem, same concept we have already read in the previously, that is eta is equals to 1 minus Tc by Th, where Tc and also Tc and Th is also represented as T2 by T1. Obviously this is nothing but is a comparison study. Here always one thing always keep in mind, that T1 is always greater than T2, that is temperature of T1 is greater than T2, always in Kelvin scale. Okay, this will be the class.